oftentimes we hear from folks or we experiencing in our conversations, Vantiq is a low-code, no-code development platform, or what is it that you guys actually do? And so the first place I really want to start is with that sort of big question. What is Vantiq as you see it? We know it's a lot more than a low-code, no-code development platform. There's a lot built into the platform that has enormous value to enterprises or organizations or even people that are building applications that do the things that we sort of enable. So in your own words, and as you sort of think of both the history of the company and where we are today, what did you build?
Okay, that's a kind of an open-ended question. I think the way I think about Vantiq is that it has two main parts. It has a development environment, which is where all the low code, no code buzzwords fit. And then it's a runtime platform for supporting mission critical, enterprise ready, real-time applications. And you can kind of simplify it to that. But these days we complicate that a little more by saying the platform supports, both mission critical real-time applications and AI intensive applications, I'll call it. And when you talk about the AI stuff, you always have to talk about, we support the whole spectrum of AI solutions, from knowledge representations to statistical models to generative AI models, right? Those are kind of the three big categories of AI systems that are available at the present time. So at the top level, that's what we've got. The part that's the hardest to understand is probably the mission critical part, because a lot of people don't really know what is involved there. And that's all about fault tolerance, availability, scalability, performance, security, right? All of the ilities that you need to build a serious enterprise application, right? We have all of that stuff built into the platform so you can use it when you build an application in Vantiq. And the nice thing about the tools is that they kind of understand that we have all of those capabilities. And so when you use the IDE to build an application, you get a lot of those ilities just as part of the natural evolution of the application that you're building. And there's still some work you have to do, but that's kind of the core elements of the enterprise readiness are there. So that's kind of at the top level, that's the way I would describe it.
So Paul, when I sort of hear this, what comes to mind is there's these two parts. There's this development platform plus, for lack of better words, we can call it infrastructure or operating system. Why bring those two things together into a single end-to-end platform?
Well, we bring them together for kind of we'll call it a philosophical reason, which is if you want maximum productivity when you're building these applications, the tools and the infrastructure have to work together very closely. And if you're, for instance, kind of the alternative to this approach is to say, okay, there's a bunch of infrastructure out there, and I'm going to build an application on top of it. And if you go to and you try to do that, in classic examples today are you try to use Azure infrastructure or you try to use AWS infrastructure, right? To do the stuff that Vantiq does, you end up with 6, 8, 10 separate pieces of infrastructure you have to integrate together to get the capabilities of Vantiq. Well, just the task of integrating those independent products together so that they all work together is probably, a 12 to 18-month project. You usually don't realize that up front, but once you start trying to get them to work together, you will see that there's a lot of work that has to be done to get them to work smoothly together. And then you still have the problem of, okay, now I need tools which make me productive when I'm trying to use my now integrated infrastructure. And if the tools don't really understand what the infrastructure is, they can't really help you very much. So by integrating the tools and the infrastructure and making sure that all of the, I'm going to call it key infrastructure that you need is already pre-integrated, that just makes the development task, that much easier and makes you that much more productive. And it makes it harder to forget some of the enterprise capabilities that you're going to need because they're kind of built in at that point.
And do you see this as an advantage, particularly for enterprises with how fast things are moving, with how new technologies are coming about, that they're challenged with legacy debt from a technical standpoint? They're trying to compete, they're trying to stay ahead, that you need this total end-to-end platform, not just to be able to build and get things out there, but to get them into production reliably, to manage them, and then as the world keeps changing, to iterate on those quickly.
Yes. I mean, that's the goal. Uh, and it's a little bit of a double-edged sword because what we try to do is provide you with all the infrastructure that you need. But infrastructure is changing very rapidly, particularly in the AI space. And so it's a challenge for us to keep all of the latest innovations, get all of those integrated into the system so you can use them seamlessly. So sometimes you run into the problem that there's some, you know, bleeding edge piece of technology that you want to use that we haven't integrated yet. And so then you have to integrate that yourself, and that's going to slow you down. But if you're willing to tolerate some of those problems around the edges, we really think that with Vantiq, if you know what you're doing with Vantiq, if you've done a project or two and you've bought into the Vantiq way of life, you are going to be incredibly productive building systems. And we see that, I mean, just in the demos that our team produces, right? And in a few days you can crank out very fancy demos, and given a couple of weeks, you can do really sophisticated things. That's kind of an example of how much power Vantiq gives you. And then the second part of that is you can keep those demos already have built into them a bunch of these enterprise capabilities. So you can keep evolving what was a prototype or a demo into a full production environment by just continuing to do the work and filling in the pieces that were left out of the original kind of demo or POC. So I think it's really powerful. You have to understand it, but once you understand it, you can do amazing things with Vantiq.
So I want to come back to the enterprise capabilities, specifically the mission critical abilities, because I think that's a incredibly unique value prop. But I want to pose a scenario. Paul Butterworth is sitting across from a CIO or a CTO at another organization, and they say, look, this is amazing tech, I get it, but I've got AWS, I've got Azure, I've got sort of everything I need there. Why do I still need Vantiq to really help me build and deploy these systems? Why do I need Vantiq as part of my tech stack?
That's a good question. And the problem with the answer to that question is it's not really the answer. The problem is really whether the CTO or CIO that you're talking to actually believes you. Because, you can give this pitch that you're going to be so much more productive using Vantiq. But CIOs and CTOs hear these kinds of stories all the time, so they usually don't believe it. Um, and I've actually run into exactly this scenario with one of the customers where we were talking with them, and their alternative was to go do a system on Azure. And ultimately, we had exactly this conversation, and they go, well, we're going to do it with Azure because the Azure guys are going to help us. And so, the risk has been taken out of the project. Um, well, we kept talking with them, even though they weren't using Vantiq. I kind of kept in touch with the guys uh, just to offer, some advice along the way about how you build a pretty fancy real-time system. And after 18 months, they basically had a prototype running, which could basically support one user. And it wasn't scale. It had none of the features that it needed. And at that point, they turned around and said, "I guess that didn't work. Let's try Vantiq." Right? And within a few months, we had the initial production system ready to go. Um, uh, and so then they're believers. But it's really hard to get people to believe up front because they've heard the story before and they just don't believe that you're any different than the other guys. And I'm not quite sure how you break through that other than saying, try it, or what we do a lot of, right, which is we put together a demo or a POC or something to prove that we can provide better productivity than what you get with I'm going to call it the traditional systems and infrastructure. I don't know if I really answered your question. I was long-winded, but hopefully it
You,
helped a little bit.
you set up nicely the sort of the next segue, which is, so if we take a step back, we have this end-to-end platform. And now I think the important thing is, so what are the unique differentiators and the features and the functions, right? If they don't believe you about the productivity because they've heard this story before, if they're still having a hard time wrapping their minds around why do I need this and how does it fit in, then I think we go into, well, how is this thing actually built? So I want to start with sort of the concept of this event-driven real time and really spend some time unpacking both in layman's terms, because I still don't fully understand complex event processing and stream processing, but we built the platform then also to be a real-time P. What is the unique qualities of an event-driven system that allow it to be something that is readily um, applicable to the challenges of today's world?
Well, there are probably multiple parts to the answer. One of the things that we're focused on is kind of this notion of we're going to receive streaming data of some kind. Um, and if you're going to gather a stream of data and you're going to try and process it in real time, then that kind of drives what the underlying structure of the system needs to be, right? Because at that point, everything needs to be able to run asynchronously. Because if you're getting a lot of events in and you serialize the processing of those, it's not going to get done in real time. That's just not going to happen. And so all of that stuff has to be done in parallel. And once you say you're going to do it in parallel, then you have to have appropriate resource management to make sure that you can survive the load that you end up with, right? And so that's all kind of infrastructure that's built into Vantiq. The other thing that comes up is, well, what does it mean to be real time? And there are a bunch of different definitions to that. I used to work in the defense industry, and we built what later became known as hard real-time systems. And that is, I get an event, I have 100 microseconds to process it and dismiss it. And if I don't get it done in 100 microseconds, the system fails, right? So you can never miss. Um, those kind of systems are not what we're after, right? We're after systems uh, which take in streams of data, but we don't need to process, we don't have a deadline that says 100 microseconds and everything has to be processed. We're trying to do it as quickly as possible so that it gets done in real time. And the real issue that we're looking for is not, how much data we get in. I mean, if we get 10,000 events a second, that's great. If we get one event every hour, that's great too. If it's necessary for you to process that one event in real time, right? The minute you get it, you need to analyze it and then react to it. That's a perfectly reasonable real-time system at a very low data rate. And the other extreme, of course, are ones that are very high data rates where all, hundreds of thousands of events a second need to be processed. And the nice thing about Vantiq is that we kind of cover that span, but we don't do the hard real-time stuff, which is, that's usually trying to control hardware in real time, right? It's the braking system in your car or the steering system in your car or something like that. Uh, that's outside the scope of what we're trying to do. I think I got lost there, but
No,
that
that was good. I want to pull on the real-time thread. So there's a whole variations of complexities that you have to solve for, but just at a sort of business value level, when you're processing and analyzing these events and these streams of data as things are occurring, and you're not having to go store them, what are some of the attributes? What are some of the values you get out of that from a business perspective beyond response time?
well, I think the main one is the ability to react to the situation, right? So the kind of the standard way to kind of think about this is we have this data flowing into the system, we're analyzing it to detect situations that need to be reacted to. And those situations need to be reacted to immediately, or the sooner you can do it, the better. Um, and there are a lot of business problems that can use that kind of capability, right? And kind of, some of this is industry specific, right? But if you're collecting, real time health data, vital signs and things, if a situation comes up, right, you want to respond to it now. I mean, putting it in a database and doing big data analysis and coming back the next day and saying, this guy's having a problem isn't worth very much. Um, and so, healthcare fits that model. Some of the security systems fit that model where, if there's an attack, uh, if there's somebody has breached a perimeter, you need to know about it now before any damage is done. Um, Responding to it later is not worth very much. Defense systems have that property as well. A lot of industrial systems have that property, since if you're doing uh, I don't know, quality control on a manufacturing line, right? If you see a problem, you need to react right away. Otherwise, that manufacturing line is going to keep running, and you're going to end up with thousands and thousands, or maybe millions of defective parts. And so getting to those things quickly is a huge value, right? The Gartner guys spent some time talking about event-driven systems and how those would be used to do, basically to run your business in real time. And that's a discussion they've been having for 25 years now. Um, uh, and there are aspects of the business that really do work that way, and real-time systems make that possible.
And when you hear folks suggest, yeah, but databases are getting more performant, they're getting more um, capable in terms of the speed at which, are there other aspects of sort of this concept of real-time data processing that you argue against and say, look, that may be fine, but you're going to be spending a ton of money, a ton of compute cost, a ton of complexity of just managing a system like that. Whereas if you're really able to do this in truly real time, if the system's designed for that, then these are the other things that you gain.
Um, yes, I think that, let's see, well, we'll probably wander around a little bit to answer that question. One of the things is that, yes, it is possible, given a certain set of constraints and the appropriate skills, right? You can build real-time systems that don't work the way Vantiq works. And in fact, there are lots of examples of those out there. Um, but, what are the restrictions that you live under? So for instance, up to a point, you could theoretically build something that's pretty close to a real-time system on a database. But you're going to burn a lot of compute resources just for the fact that you're continuously sending queries to the database in real time, both to stuff in the database and to get stuff back out. And that's going to be more, there's going to be much more overhead in the database world than there is inside of Vantiq to solve that same problem. The other thing it does is it adds some discipline to the process, because in your real-time processing, it's not like I want to have 5 years worth of data, and every time I get a new event, I'm going to analyze all 5 years of data with respect to this new event, right? That is not going to happen. It's simply impractical to apply that level of resources to the problem. Um, and so what you really want is you want to understand exactly what you need to do to the real-time data to detect the situations that you're interested in. And typically that means you can do it in a much more efficient fashion than you would typically do it with a database, right? Because databases are going to want to run queries, and those are going to be more expensive as you have more data available. Let's see, what else, fits in that category? I think there's more parts to that problem, but I'm kind of drawing a blank at the moment.
Yeah, I mean, a big thing I hear you say is purpose built for this real-time analysis is a key differentiator. But architecturally, total cost of ownership of the system, not only are you getting better performance, but it's going to be a lot less expensive. You're not going to have the same types of restraints that you have. One other thing that I've heard you comment on is this notion of complex event processing and thinking about different pieces of data coming from different places that need to be combined in a window of time that take just stagnant, what I would call stagnant data, or just the data stream.
Yes. So that is all associated with how you detect situations and how you process streams of data. And the real problem there is you typically don't have one stream of data, you have multiple streams of data. And the data is all related. But the data is only related with respect to the time at which that data was collected, right? So my dumb example is if I'm, if I'm collecting, I don't know, uh, uh, blood pressure and heart rate at using two different sensors. The blood pressure and the heart rates only correlate over a relatively small window, right? If I get a blood pressure from a week ago and a heart rate from today, that doesn't mean anything. There's no relation between those that's useful. And so one of the things that we have done in Vantiq is we make it very easy to basically correlate the data streams as they arrive, right? And this is the first folks to do this were the complex event processing guys. And I always laugh at that because from a marketing perspective, I can't think of anything worse that you can call yourself than a complex system. And unfortunately, it was true because you pretty much needed to have a PhD in order to make those systems work. And so what we've tried to do is simplify that process primarily through the tools, right? Because the tools allow you to describe the correlation constraints in a very easy fashion, whether those are kind of matching up identifiers or matching up qualifying conditions or time windows in which events arrive, right? All of that is very easy to describe inside Vantiq. And then the runtime system is organized so that it's very efficient for us to run those correlations. So we can run them at, thousands of correlations a second without any problem. Typically, when you do that kind of on your own, you aren't going to get that kind of throughput through the system because the amount of overhead involved in trying to, just the problem of trying to capture things that fall in the same time window. If you're not using the kind of fully asynchronous stuff that we're using, the overhead associated with that becomes huge as you get, thousands, hundreds of thousands of threads running in your environment. So all of that is designed specifically to solve the problem of, not just ingesting streaming data, but getting it all properly correlated so you really can detect the situations that you need and detect them efficiently, right? And the other thing we do is we try to keep all the data that we're using to do all of this work in memory so that we're not, every time a piece of data arrives, we're not out consulting a database, which is going to create a lot more overhead and is going to reduce the kind of we'll call it the throughput rates at which we can run the system. And so keeping all of that in memory helps. But if you're going to keep it all in memory, then you have other problems, right? So if there's a fault, what happens to all your in-memory data? I mean, you don't want to lose it, or in many cases, you don't want to lose it. So then we have features available to replicate that so that you can recover from compute failures in the environment. And it kind of goes on like that, right? There's more and more layers that you need in order to make all of this work transparently and at the performance levels that we need and at the availability levels that we need. So that all be, when you try to dig in and do all of that, that's a hard problem.
Yeah, and I think it really speaks to the functionality of the platform being a lot more than just sort of what maybe looked at on the surface, because I can take a number of use cases in which within a defined window, these various points of data mean something. They're coming from different places, but they mean something. And then even more importantly, the averages or the trends of those data over time mean something else, right? So the situation may be evolving, and to do all of this in memory is not only more performant, but again, it's a efficiency gain. But then even further, the platform has the ability to back that memory up and add some levels of fault tolerance, so I don't lose that data. So it's this very high degree of reliability in not just building the system, but how do you operate a system if I'm monitoring a factory floor, or if I'm monitoring a supply chain, or patients in a hospital. I need to know that I have those features built in. That becomes immensely valuable.
Yes, yes, because those are all things that require, high availability, right? If your hospital system is actually monitoring patients, right, it can't be down. Um, Same thing on the factory floor, right? The factory floor, if the systems go down, the factory has to stop. That's not acceptable. And so these are the kinds of features that you must have in order to make those kinds of applications work.
Yeah, and the same thing for a smart stadium or a building or a public safety. These things are, we're sort of expecting them maybe counterintuitively to just work. They often don't, but part of that is the technological challenges of making a system like that work.
Yes, yes. And a lot of the underlying technology that's needed was all, originally developed in the telco space, right? Because phone services, the original phone services, you didn't want them to fail. And as those became data services, you didn't want those to fail. Um, and so a lot of technology has been built up around that. And since we've had past experience in all those areas, we've incorporated that into Vantiq. And so now you get to take advantage of that when you build applications. And all your applications may not need that, right? If you have a reporting app, I mean, it gets these features too. It doesn't really need them because if your report doesn't show up if it shows up an hour later, nobody really cares. But um, the features are all there for the critical systems that you need to build.
Without going down the AI rabbit hole, because I feel like that will be its own series of calls, another thing that strikes me as a really unique value proposition is anytime I'm using a traditional AI model or machine learning model, and I'll point to the application Neil built with NeuroSync. I've got different data in different formats, some of it's structured, some of it's unstructured. If I'm really trying to get that to a model, I need it all to be somewhat cohesive. And so this becomes an even different approach where you see a lot of data science time spent on just cleaning the data and organizing it in a fashion to make it usable for the model. We have a lot of features in the platform that enable you to do those transformations as the data is in flight, or to sort of get everything in the case of NeuroSync, get it into a single JSON payload. Or Brett often shows incorporating a transformation pattern to add a timestamp because the analysis of that data is really predicated upon the time that it came, but that piece of data is missing from the data flow. Can you talk a little bit about the importance of that and where Vantiq really excels in that sort of data processing or transformation as it's coming, and then how that really becomes valuable for an enterprise or a company trying to run an AI model? I call it in the workflow. We call it real time, but from a doctor standpoint, it doesn't help me to give me a result of something 5 minutes after I've left the patient's room, right? I need it now because that's my workflow.
Yes, yes. And the type technology you're talking about here, this is kind of in what I consider the integration space, right? Which is I have to gather the data, so I have to pull it in from the sources that produce the data. And then I have to take the data that I get in and I have to enrich it with additional data that makes it more meaningful. Um, and then I need to do, analysis on it to figure out what it means. Um, so that's kind of the initial part of the flow of a data stream or a collection of data streams if you're correlating them. Um, and so, a big part of Vantiq is all about, okay, how do we get your data, right? That's why we have integrations with a zillion different systems. Um, and then once you get the data, how do you enrich it, right? So, if I'm getting a reading from a temperature sensor, what I usually get is the ID of the sensor and the value. And but that's not enough data to do anything with because without knowing what that sensor is attached to, whether that's a patient or a machine or some ambient temperature reading, right? You have no idea what to do with it. So the first problem is enrich the data so it has enough context so that you know what that piece of data is about, what it means, and how you should analyze it. Um, and then there's always the question of, especially in the AI space, right? A lot of the analysis of the data is via statistical models, basically neural networks that have been, pre-trained with labeled data to detect particular or identify particular types of objects or situations or whatever you want to think of them as. And so another thing that we do is we integrate that capability into the system so that when a piece of data shows up and we get it enriched, we can send the enriched data to one of these neural nets and it can classify it. Another one that comes up, and you see this when you're looking at physical sensors, is that these things are electronic devices, and every once in a while they glitch, right? Or you get a transient spike in the electrical signal, maybe from some external interference. And so you need to recognize those situations so that you can filter them out, right? Because that reading is wrong. And if temperatures are going along at 65 degrees and all of a sudden they go to 200 for a reading or two, right? That's not a valid reading. And so you need to have a way to filter those out. And we have algorithms for doing that are built into the platform as well. So lots of different ways that you analyze the data, and that, for any data system, that's always the first problem, is making sure that the data you're getting is enriched in the proper format, is correct, and then you can go on and do more sophisticated analysis on
it. Yeah, one of the things you're taught in medical school is context is everything. And the first cardiac arrest that I was alone responding to, the patient was brushing their teeth, so they were shaking the leads, and it looked like they were in VFib arrest. So false data can cause a lot of bad, high levels of stress for an individual, but also enterprises lose a lot because of faulty readings and false data. And I think that ability to contextualize and really create intelligence is a huge part of what the platform does. I
it.
hear.
And that's a perfect example of where you want to correlate some data. Right, because if you had the sensor readings and you had video of the patient brushing their teeth and those correlated at the same time, you'd realize what was wrong.
Right, right, exactly. I hear so many different sort of pieces of value, right? Beyond just the end-to-end platform, the fact that it's architected from the ground up to be event driven, to be real time, it has all of these unique features. Why do you think, and maybe this is both an open-ended question and hopefully a softball, why do you think others haven't built a platform like this? Why do you think AWS or Azure haven't taken on to event-driven architects as sort of things that they offer to their consumer base?
Um, well, that's probably more of an opinion than anything else, since I don't really know why they do what they do, not being, not being embedded in that world. Um, but like if you take something like AWS, they're they're not trying to solve just the real-time event-driven problem, right? They have millions of customers, and so they're trying to build a portfolio of products that support those customers doing thousands of different things. And so it's a lot easier to build independent primitive capabilities for each of the things that users might need, um, than it is to try to build these integrated systems, which are, admittedly hard to build, right? We've spent a huge amount of time building Vantiq. An example of that is, right, you have Kafka, which is a messaging system. And yes, it will process real-time streams of data, but it will process any other kind of data that you want to put in a messaging system, right? It doesn't have to be real-time message streams. And so it's applicable to a bunch of applications that Vantiq isn't applicable to. So I kind of see that as, the especially the bigger vendors, they want to provide capabilities that solve lots of problems rather than, basically optimizing a specific problem. That's just my first guess.
And do you see sort of the database centric evolution of these companies because they started as core databases, that it would be incredibly complex for them to evolve from that to something like Vantiq?
Well, you have to think differently, to do this asynchronous stuff. And yes, a lot of people are database centric, but I think among like vendors, the big vendors like Microsoft and AWS, they have plenty of people that understand the real-time problems. It's just not a focus. Building a product specific to that is just not their focus. And because they do, right? Like, AWS has Kinesis, which is basically specifically designed around streaming data. But rather than building a bunch of tools and other infrastructure around it to solve more real-time problems, they just go, well, this helps you with a specific part of the streaming application problem, and then you can just use other tools to deal with the rest of it.
And that goes back to your earlier comment of stitching multiple things together, the complexity, the cost, et cetera, that's going to come with that.
Right. Because each piece of infrastructure has its own set of assumptions and constraints built into it. And so getting all those things to match up is always really hard.
Yeah, it makes a ton of sense. When you think of sort of our event-based architecture, one thing that we hear about is that you all in the team had to build your own event broker. And what are some of the unique characteristics or attributes of our event broker as compared to what an alternative may look like?
Okay, let's see. Well, that goes back in time a little bit. That work was done a lot of years ago. Now I'm going to have to remember all the details. Some of this is all around performance, right? Because we want, again, we're running these, in theory, we're running these very high data rate event streams. Now, again, all applications don't run at those rates, but at least some of them do. And so we needed an event broker that would run at, hundreds of thousands of events a second. That means that any sort of delay or any place where the messages have to be processed serially is just out of the question, right? Everything has to run in parallel if you're going to run at those rates. The other thing that happens is we're focused on, one of the big changes was we were focused on fault tolerance. A lot of the event brokers are single instance solutions. So there is an event broker, it sits on a machine somewhere and it runs. Well, if there's a failure, you don't have event broker services. We were trying to build it so that the event broker function was distributed across all the instances of Vantiq that are running, so that if there's a failure, we can continue running as part of the fault tolerant architecture. The other thing that we did was that typically an event broker does one function, which is it grabs a message, it looks at it, and it goes, this message needs to go to A, or this message needs to go to B. because we have a lot of power in the Vantiq platform, we try to add more value. So for instance, we can not only say this message needs to go to A, we can say this message needs to go to A, and oh, and A wants it in this other format. So let's transform it as part of the event brokering process. I don't think any other event broker actually has that capability. And that's some of the stuff that we've patented in the event broker space.
Yeah, and that level of performance and that level of sophistication in and of itself is quite valuable, particularly for a large enterprise that's trying to deploy a system like this, where you do have multiple streams of data coming in at different rates, but that ability for the event broker itself to do the data transformation is not only quite unique, but it seems like it's really unique to us because of the patents that we hold, but also because I assume in the complexity of building that type of event broker.
Yes, yes, it is. You have to do. It has a lot more capability, so obviously it's more work to build that. But it's incredibly powerful for the user because, right, you're integrating a bunch of systems together. Event brokers always sit, in the middle of routing stuff between various systems, not just routing stuff internal to Vantiq. And, and as you try to integrate with other systems, the biggest problem is always matching message formats and matching data formats because every system makes its own assumptions about what the data looks like. And so being able to build that kind of transformation directly into the event broker means you don't have to build it into your applications. And so when you try to hook, two new applications together, it's a lot easier to have the event broker do the transformations than it is to get it to the application and then say, application, change this. Or worse, what happens is you have to send the message to another application that you have to build that does the transformation and then forwards it on to the target system. So in theory, this should make the entire kind of integration problem much easier and make it much easier for you to gracefully evolve how all your systems connect together.
Yeah, and the last minute or two of what you said, I think is one of the most important problems we solve from an integration standpoint, particularly in any organization that's got all of these systems and applications that they're either unwinding, they're adding on, et cetera. Getting these things to work together is often a nightmare. And anyone in the
Yes.
tech space will tell you that. Solving that problem while still allowing you to build on top of and iterate is an enormous value proposition that sits within our core infrastructure.
Exactly. And I'm happy to take the argument one step further, which is most integrations are done at the API level. APIs are so tightly tied to the internal workings of the applications that the API, that expose the API, that many times if the internals of the application change, the API has to change. And that means everybody who uses the data has to change to adapt to the new format. If you use events to do your integration, events are rarely tied to the internals of the application, right? Because they're usually defined separately. And so that means that if an application changes, the events that it exchanges don't necessarily have to change. And in fact, it may be that when the application changes its internal formats, it has to build transformations to map it into the events that already exist throughout the environment. That is a lot more efficient to do than to say, oh, I'm just going to change my internal representations. And oh, by the way, anybody who uses my data now has to change, right? Instead of changing one system, you have to change 8 systems, a dozen systems, whatever it is. That's a much more expensive task. And so how your integrations involve is much easier if you're using kind of event-driven integration rather than API-driven integration.
Yeah, and I think probably the most poignant. Oh, go ahead, Marty or David.
Oh, it's David here. Sorry. I was going to say, Paul, I think one thing that we're hearing more and more of talking to Gartner and a number of the analyst groups is the multi-agent systems that are starting to be developed, or the research around them is starting to also point now to an event-driven architecture as somewhat of a necessary backbone to support that, especially given the loose coupling nature of an event-driven architecture and what you're talking about in terms of resiliency, reliability. Are you seeing that as something that Vantiq's platform is now somewhat uniquely suited to handle?
Absolutely. And when we talk about the AI stuff and multi-agent systems, we can go into this in more detail. But the first thing we've done is we've taken the A to A protocol, which typically runs on HTTP, so it's pretty much synchronous. And we've just layered the protocol messages on top of our messaging infrastructure. So it's all asynchronous right from the start. And that means that a set of agents can much more easily collaborate than they can if they have to run, using synchronous protocols. Because even A in its synchronous case, it has to phony up asynchronous activities because there's simply no way that all of the interactions that you need to do from agent to agent are going to be synchronous. Anyway, we can go into that. That's a long discussion. We probably should do that in a separate session.
Yeah, I want to be mindful of time. So, kind of recap a number of the things that we've heard today that I think are really important, and just get you to respond. One, the idea of combining sort of this end-to-end platform that's both you have the ability to develop, but the infrastructure that's necessary is levels of productivity gain for the people that are developing these systems. Enterprises will gain levels of productivity because of the performance, the cost, the architecture itself is quite unique in some of the actual technical problems that it solves. So sans, if you don't have a Vantiq, if you're not maybe building that type of application, you're still going to run into a lot of these data integration problems. You're still going to run into a lot of these problems of performance. And so there's just layers on top of this end-to-end platform that are addressing problems that nearly every organization at some stage in the next coming year, they're going to face, if not facing now. And so this end-to-end platform really does give you levels of value at multiple different places, irrespective of whether you're developing or not. If you are developing, obviously there's clear productivity gains. But if you're just an organization who wants to run these types of systems, you're going to encounter enormous challenges that are going to need to be solved, and we've solved those for you.
Yep. That all makes perfect sense, and the competing strategy from kind of a sales perspective is that you walk into a customer and they go, well, I don't want to use your integrated infrastructure because I want best of breed for each piece of the solution, right? And that forces them to do integration because they're going to select all the pieces and put them together. And if you've got the time and money to do that and the skills to do it, okay, go ahead. It's just going to cost you a lot of money. But if what you really want is you want to get applications built and you want to get them out as quickly as possible, I think Vantiq is a lot better choice.